Okay, hello. Looking at day 21 here. So I'm going to click on the top link here and find day 21. It's right here, conditional probability, the one with the tables. Start with the homework. All right, copy the slideshows right here. I opened it up in a different tab up here already, just in case we need it. All right. Essential question for the day. Usually the second or third slide. There it is. How can we find the probability of one event given that another event has already occurred? Again, that's the idea of conditional probability. We're looking at two events. They're dependent. One affects the other. All right. So after the first one occurs, it alters, depending on what happened first. It alters the probability of the second one. All right, three tools we discussed in the video. I think they're right here. Okay, so we use tree diagrams, contingency tables, and the formula. All right, to find conditional probabilities. And again, it's not a screwdriver, it's not a hammer, it's not a compass, it's not a drill bit, and it's not a microscope. All right, so I just gave you all the wrong answers. All right, number three. Again, y'all, we're using a formula here. We're probably given that A and B is 30.38. 38%, 0.38, but use the decimal when you're dividing. The and goes on top, so 0.38 goes on top, divided by 0.5. All right, I think it doubles it then. 376, yep, I see it right there, okay. Well, that should be the purple folder done. Moving to the green, the warm-up. It's three vocabulary words. All right. Probability of one event given that another event has already happened. That's conditional. That's the idea of conditional. It's a probability. Probability of something happens, but given that some other event has already happened, and they're dependent, so one affects the other. Relative frequency, it's kind of like a probability. I mean, it really is when we use tables. Again, it's a fraction. Right? Contingency tables. A table is rows and columns. Right? Data frequencies displayed in rows and columns. All right. And you can always pause the video. I know I'm going fast here. The worksheet is right here. Open it up. It's right here. We're going to do it. All right. I think you guys can do this one online, actually. Again, add these all up. Okay. Was that 80, 91, or 81? Yeah, 81. Add these up. That's 9. Add up the totals. So that's 90 down here. So this must be 31, 59. 59 plus 31 is 59. Yep, there's 90. All right. Probability they have a diploma. The big number on the bottom is a 90. Again, it's not conditional. There's no line there like this one. This is conditional. So that's what we're talking about here today. This is just a probability. If we pick someone, they have a diploma. So start with the total on the bottom, 90. Again, the total that have a diploma. High school diploma, yes. 81. Go ahead and simplify that. All right. Has a diploma and experience. We're just picking someone. All right, 90 against the bottom. Diploma and experience. They have a diploma, yes. Experience, yes. It's right there, guys. 54 has a diploma and experience right there. Yes, yes. All right. Again, simplify it. All right, these bottom two are conditional. See this line right here? This is saying the probability that they have experience, given that they have a diploma. Right? Again, when you see this, think of this as the fraction bar. Just kind of draw it like that. So has a diploma. What's the total that will have a diploma? Come right over here. 81 is our new bottom. See how we constrict the sample space to only who has a diploma. That's what conditional probability does. It constricts the sample space. All right. I hope you can hear me. All right. So of the 81 that have a diploma, how many have experience? So just come across on this row right there again. 54 have experience right there. And go ahead and simplify it. I'm just gonna do it like that. All right. Has no diploma but has experience. Again, be careful here. Has experience is on the bottom. So has experience, you got to use this column now. Yes, 59 is on the bottom. 59 is now on the bottom. Has experience? Yes. That's now the bottom. And has no diploma? All right, no is, there's just 5. Of this column, 5. Again, given they have experience, how many of those do not have a diploma? All right, moving right along here. Let me check my time. All right, guys, we got to hustle here. I might have to make 2 videos. All right, again, do the totals. I guess I could do them real quick, just a second. Okay, I got the totals here. Again, you guys, number 5, that's not conditional. They're just saying if we pick someone, what's the probability that they're male? So use the 2803 as the bottom. 2803. And how many males total? 1136. Again, divide it. You can turn it into a decimal. All right. That's the probability you have a bachelor's degree. Again, the bottom is a 2803. That's all of them. It's not conditional. There's no line here. Like this, here's a line, like that one, or that one right there. Right, there's no line here. So the degree is bachelor's, right across there, 1456. All right. Now, number 7 is conditional. The probability that they're female, given that they have an advanced degree. And think of this line, the given line, as a fraction. How many have advanced degree? Advanced is right here, 669. And of those, the females are 376. Again, we constrict the original sample size, not the 2803, just down to the ones that have an advanced degree, and how many of those are female. All right. Same thing, go like this. The bottom is male. So how many males are right here? 1136. Of those, degree is not associates. So that's bachelor's, 598 plus 293. That's advanced. Add those up and divide by 1136. All right, guys, this one looks like they already have the table in there, or the totals are there. So selecting a female from the class is 100. Oops, just a minute. There. How many females? Right there, 47. That's 47%. All right, probability of selecting an A student, again, it's out of 100. How many A students? Right there, 29. The total, okay. All right, the probability we select a C student given that they're already male. Fraction bar, the male total is right here, 53. Of those, C students, 14. All right, it's a little different. The numerator is the same, but this is different. Given that they're a C student, what's the probability that they're male? Given they're a C student. So here's the C students, 27. That's the bottom. The denominator changes. Because of them, how many of them are male? Same, 14. The same 14. But a different probability. Because we're constricting to a different sample size. Okay, next we use the formula. Again, the formula. The probability that B happens, given that A has already happened. Probably A and B happened, divided by the probability that A happened. All right, that's what it is. So the and goes on top. All right, the probability that she studies and passes her test is 17 out of 20. That's the top. If the probability that she studies is 15 out of 16, that's the bottom. Find the probability that she passes her test given that she studied. That's what this is right here. Well, you might remember, guys, we're dividing a fraction into another fraction. Invert and multiply. Just write the top one, 17 over 20, times. Flip this one around and multiply. 16 over 15. And just multiply across, all right? Go ahead, you can go ahead and do that. Same thing here. Sue goes to Mexico in the winter and to France in the summer and to France in the summer. 40%. So that goes on top. That's the and. 0.40. The probability that she goes to Mexico in the winter is 60. All right, find the probability she goes to France this summer, given that she's already been to Mexico. Right? That's what this is right here. All right. Two independent events. All right. Probability that A and B happen. All right, so multiply them together. 0.6 times 0.25. All right, go ahead and do that. Now this one is saying the probability that A happens given that B has already happened. But these are independent events. All right, this is the trick question. But the probability that A happens is the same. It doesn't matter if B happened or not. It doesn't matter what happened with B. This equals the probability of A. And that's 0.6. All right, guys, I got to stop the video. Thanks.